Hello everyone, this is section 1.1, which is about functions. So, so chapter 1 is actually the revision of what you guys studied in college algebra, or basically in algebra class. All right, so we're gonna review a few things in chapter 1 about the college algebra, and then we'll move on from there. All right, so the first thing yeah, we're going to see is functions. So the functions definition, well, I've written right here, is a special type of relation where each unique input has exactly one output. All right, so if you see an example, let's say the example says that each student has an unique ID number, right? Because one person gets one ID number, right? Because in Wichita, I think each person has just one ID number. I don't think each person has two different ID number, right? So if, well, if you have something like this kind of case, then we say this kind of case is a function. So let's see a picture of it. Let's say this is input. And let's say this is X. And here, let's say output. Output, let's say Y. And also this input and output, we can say input, we call domain, and output, we can also say domain, output as a range. All right. So now if I give some value here on input, let's say A, B, C, and an output, let's say D, E, and F. All right, so now here we're going to say that this A maps to D, B maps to E, and also B maps to F. So here we get a condition where this input B has two different output, right? E and F. So these kind of case, we consider this is not a function. All right, because it shows that one, let's say if we consider this kind of case, we're saying that one person has two different output or two different ID, right? So this kind of case, we consider this is not a function, all right? And also if you see graphically, let's say we see a graph. Let's find if this function, so this is x-axis, this is y-axis. Let's consider whether, well, let's find if this is a function or not. So to find if a graph is a function or not, then we use vertical, vertical line test. All right, so the vertical line test, what we're going to do here is we're going to make a vertical line that goes through this graph. And if we see the vertical line crosses this graph more than once, then it is not a function. So here it's going to cross right here and right here. So this vertical line is going to cross this graph twice. So again, in this case, we consider this is not a function. All right. So similarly, let's say if we have this kind of graph, is this a function or not? So in this case, it's a function, right? So if we make a vertical line, then this vertical line crosses this graph just here once. So in this case, yeah, this is a function. All right. So this is the idea of a function. Now, let's go to the next page. Now let's see the function notation. So, function we write like this, right? Because if this f is the name of the function, this x is, well, we say the function is in terms of x. So if you write something like this, then we can say f of x, let's just say a random function, let's say x squared plus 2. All right, so the reason I have x here is, this x here is because I have x here. So this function we say in terms of x, simple, right? Now, if I change this x to, let's say, to a, then we also change this x to a. So we say a squared plus 2, right? Similarly, let's say if I change the x to a plus h, then we need to change this x, just x, to a plus h, and everything else is going to stay the same because we have square 2 on the top right, 2 plus 2. So instead of x, now we're going to have a new thing, a plus h. All right. Okay, now let's go to the domain. So domain, we said it's x input, right? We said domain is input. So here we say domain is input. So basically now here to find domain of a function, we are considering all the input or all the x values that are possible. So let's say the function we have log of x plus 2. All right, so now to find the domain of this log function, because we have a log here, if you guys remember from the algebra, so we consider, let's say if we have log of a positive number, any positive number, we get a value. That's possible. All right. But now if we consider log of a negative number, any negative number, log of, let's say, -1, -2, doesn't matter, any negative number, it's always undefined. That's not possible. It's always undefined. All right. So, so what we got from here is we are saying that since the log must have a positive number here to get the value, so that means this x plus 2 must be a positive number, right? So now mathematically, this is not how we, this is not a correct way to write. So this thing we can write in a math, we can write x plus 2 greater than 0. So if we say greater than 0, it's a positive number, right? So now after this, we get x is greater than -2, right? So now we need to write our answer in interval notation, all right? Interval notation. All right, so the interval notation, the way we write this thing in the interval notation is, well, first we can see a numbered line. Wait a second. Okay, let's make a numbered line. Let's consider -2 is somewhere down here. And then we're saying that x is greater than -2. So in this case, x is strictly greater than -2. So if we have strictly greater than, then we consider open circle. And then we're saying x is greater than, so from here, it's going to go to to the right. So everything on the right is our solution. So from this side is going to be negative infinity, and this side is going to be positive infinity, right? So now to write this in interval notation, this thing, interval notation, the interval notation is everything that is possible. So from negative to infinity, right? So on the left hand side, since we are not considering, or we are not including negative, because we said it's strictly greater than, so if we are not including, we are going to say a parenthesis, and also on this infinity side doesn't have a stopping point. We don't know where infinity is going to stop. So that's why also we consider here a parenthesis. All right. Okay. But what about, let's say if we have x greater than equals to -2. So in this case, again, it's similar to that, this case. Now, here we have a strictly greater, we have greater than equals to. So now, when you consider this number line, -2. So from here now, since we are including, because we have equal sign, so if you are including, then this is going to be a closed circle. All right, something like this, a closed circle. And again, from this, it's going to go to the right. So we're considering this, right? So now again, the way we write the interval notation, or let's just say in. So the interval notation is going to be from -2 to, well, this is going to go to the infinity. And since now here we are including, right? Because we have equal signs. So if you're including, it's going to be a square bracket. All right. And here again, infinity doesn't have a stopping point, so parenthesis. All right. Similarly, let's, so yeah, so here we are saying, okay, if I go back, so here, since we are trying to find the domain, so here, well, all this process was basically to find the domain. So since we are saying that these are the x values possible, so this thing we consider it is a domain. All right. So similarly, let's say we want to find the domain of another function. Find domain of, let's say, f of x is equals to 5x plus 1. Let me write that again. Oops. 5x plus 1 over 3x minus 6. All right, so 5x plus 1 over 3x minus 6. So here, this is a fraction. So whenever we deal with a fraction, and we are trying to find all the x values possible, right? So in this case, we know that the fraction, any number or anything, let's just say a, anything divided by 0 is undefined. All right? Anything divided by 0 is undefined. So that means here with this function, we need to consider that if we have this denominator 0, then this whole function is going to be undefined. So that's why we need to consider this denominator is not equals to 0. As long as the denominator is not 0, this whole thing is going to work. All right, so that's why we're going to say minus 6 is not equals to 0. All right, so if this is not equals to 0, then we get, well, if you solve for x, move this to the other side, 3x is not equals to 6, so x is not equals to 2, right? So here what we're saying is all real numbers is going to work except 2. So if you consider a number line, so let's say 2 is somewhere down here. So we're saying now here, we're saying that 2 is not going to work, right? So here we say 2 is not going to work. So that means here, except 2, everything else is going to work. So all the real numbers from negative infinity to positive infinity are going to work, except negative 2. So now the way we write this in the interval notation, so we're saying that from negative infinity to 2, so from negative infinity to 2, and also from 2 to infinity. But we are not including 2, right? So infinity doesn't have a stopping point. That's why we have a parenthesis on this side, and also here we are not including. So parenthesis, here again parenthesis, and parenthesis. So now here in between we're going to say this u. So this u is also called r. And the reason we are saying r is where our value are going to be either on this side or on this side. So that's why we have this r in the middle. And this is just the way you write when we get these kind of conditions. All right. Now, let's find the domain of two x minus 8. So it's square root of 2x minus 8. Now let's find the domain of this function. Now in this case, the square root, so we know that square root of any positive number is possible, right? We are going to get some value. Square root of 0 is also possible because the square root of 0 is still a 0, right? This is also possible. Now, square root of any negative number, well, we will get we'll get an imaginary number, but I don't think we'll get a real number. So we cannot get a real number from square root of some negative number. Okay, so here, since we're just considering the real thing for right now, so I'm just going to say this is not possible. All right. So so that means here, this thing inside the root, this thing inside the root must be. So since we get these two conditions, right? We get these two conditions is true, or these two conditions are going to work. So that means we are saying that 2x minus 8 is positive and also 0. So when we say positive, we say greater than 0, right? And since we are also including, since we are also including 0, so if you are including, we're going to have equal sign here. So that's why you say 2x minus 8 is greater than equals to 0. So now here, for this, when you solve for this, we can just move this 8 to the other side. 8 is greater than equals to, 2x is greater than equals to 8. And now divide 2 on both sides, so x is greater than equals to 4. All right, so here when you consider a number line, 4, let's say, is somewhere down here. Now we're saying x is greater than equals to 4, so including 4, it's greater than, right? So it's going to go to the right. So from 4 to infinity. Okay, so so here, now the way we write this interval notation. So here, sorry, when you're including, we're going to do a closed circle. Sorry, I do that. Yeah, this must be a closed circle. So interval notation is from 4 to infinity. Now here, since we're including 4, so that's why we have a square bracket. Here we're not including, that's why our basically infinity doesn't have a stopping point, so that's why we have parenthesis on this side. Okay, what about a function where it doesn't have any fraction, it doesn't have a square root, or it doesn't even have a log, just a simple function. Let's just say x squared plus 2x plus 1, something like this. So something like this, without a fraction, without a square root, without log. In this case, the domain, well, everything, all the x values are going to work here in this case. If you just take any x, it doesn't matter, any x or any real number. So negative whatever, negative billion, negative thousand, negative 1, 0, 1, whatever, it's going to work, right? So that's why the domain, let me just say t, the domain, are all the real numbers. So the way we write that is from negative infinity to positive infinity, and because this will give all the real numbers. And since we are we don't know the stopping point of the infinity, so on both sides we are going to have a parenthesis. All right. Okay. Now let's go to another section. Now, yeah, this is it for section 1.1. Now let's go to another section. Okay, so this is section 1.2, which is about graphs and transformations of graph. All right, so so here first we need to know the basic form, or the set of the basic functions. So there are a few basic functions. Let's consider the first one. F of x is equals to x. So when we see just the set of this kind of basic functions, it's always straight line, something like this, that goes through origin or this point 0, 0, 0. All right. And another one is f of x is equals to x squared. So in this one, oops, this is not straight. Anyway, yeah. So yeah, here we are going to get a parabola, because x squared, the shape of the graph is always a parabola, something like this. F of x x cubed, or x to the power 3. It's always going to be something like this, right? Another one, x square root of x the graph is always like from this point, it's always like that. Okay, what else? Okay, yeah, f of x is equals to cube root of x. So in this one, it's gonna look quite similar to this, but here it's gonna approach from y-axis like this. Here it's approaching from sorry, here it's going to approach from x-axis like this. Here it's approaching from y-axis, right? So the graph would look similar, but it's slightly different. It's going to be like this. All right, so it basically this looks parallel to y-axis. Here, this one looks parallel to x-axis. All right. And the last one, x is equal to absolute value of x. Here, so the graph for this one is going to look like okay, let me do this again. I'm getting used to with this writing pad because I don't use this a lot. So anyway, all right. So yeah, the graph is going to look something like this, right? Okay, now let's go to the next page and let's look at the transformation thing. So here, the transformations, well, let's say if we have y is equals to f of x. Okay, this is a basic function. Now, with this basic function, let's add some extra things. So let's add plus some number. Let's just say k. All right, so here, if we have something like this, then it's basically the graph is going to move k units up. All right, and another one, and if we have a basic function f of x, and now we are going to, if we say minus k, then it's going to move k units down. Okay, so what does this mean? Is basically now let's see example. Let's see an example. Let's say y is equals to x squared. All right, so we know that the shape of the graph of this kind of function is like this, right? Now, when we consider this extra thing that I said here, now let's say y is equals to x squared. Let's say plus 2. All right, so here, since we said if we add something with f of x, like this, then we are going to move k units up. So from here, everything is going to move k units up. So 1, 2. So from there, the graph is going to look again something like this. All right? So x squared minus 2, then it's going to move from this original graph, which is y is equals to x squared. From this original graph, it's going to move now 2 units down. So 1, 2, and from here, the graph is like this. Okay. Now another one, again, if we consider again the same. Okay, this is one example. Another one, y is equals to f of x. Right, so this is the base function, and now with this function, now let's consider y is equals to f of. Now here we consider this k outside the function, right? Outside f of x. Now here we're going to consider this extra term inside the function. Let's say x plus k. All right, so now if we have here, we said if this is outside the function with the plus, it's going to move up. With the minus, it's going to move down. So here with the plus inside the function, plus k, then what do you think? It's going to move to the right or left? It has to be one of those. So maybe just looking at the plus, we think, okay, it's going to move to the right, but it's not the conditions here. In this case, if the k, or if we're adding these kind of thing inside the function. So if there is a plus, then it's going to move left, k units left. Right? And with this one, with the minus k units. So again, if we consider the same thing as a base function, so we know that the graph is like this. Now, okay, now y is equals to f of x, which is plus 2. Then that means here with the plus 2, it's going to move to the left. So all of these are going to move 2 units left. So let's say 1 here, 2 here. So from this point, I'm going to have a new graph, something like this. All right. And if we have a minus 2, x minus 2, then it's going to move to the right. Something like this. Okay. Let's go to the next page. Okay, now now let's look at again the base function is y is equals to f of x. Now if we consider now this condition y is equals to negative f of x. Now this negative is outside the function, and basically we are multiplying this negative to this, right? The function. So if it is something like this, then we are going to say reflect this the base function, reflect y is equals to f of x over x-axis. All right. So again, if we consider a base function, it's an example. If we say a base function is y is equals to x squared which is this, right? So here, y is equals to negative. So this negative is outside this square. So when you consider something like this, now it's going to reflect over x-axis. So we say this is x-axis, right? This is x-axis. This is y-axis. So now we're going to reflect this graph over x-axis. So the graph is going to be something like this, right? And again, considering this as a base function, we are also going to get, let's say if we have y is equals to some number, of x. Then here we are going to get, so here in this kind of case, we are going to say multiply the y coordinate by a. So whatever number is in the front, we're going to multiply the y coordinate of the base function, and that way we get a new graph. So let's see an example here. So let's consider the base function again. Y is equals to x squared. All right, and here this point is 0, 0. Let's consider this point here, which is 2, 4, and this point here, let's consider it's -2, 4. All right, so now now we need to find a new graph of this function's y is equals to 2x squared. So here, yeah, if we get a number outside the function, something like this, or if you're multiplying something like this, then then in this case we multiply the y coordinates by a to get a new graph. So what does that mean is multiply this 2 to the y coordinates of this graph, the points on this graph. So here, when you multiply 2 by this y coordinate right here, this y coordinate right here, 2 times 0 is still a 0, so it's going to stay right there. Another one, 2 times 4 is going to be 8, so the new point is going to be, let's say, somewhere down here, 2, 8. And also here, we multiply 2 to the y coordinates, so again, -2 is going to stay the same, and 2 times 4 is going to be, let's say this is -2 times 8. So we have now this 3 points. So now let's make a new graph. So there must be a curve here. So anyway, yeah, so this is a new graph of this function. All right, so yeah, this is called transformation. So basically, well, on the homework problem, you might see something like, let's say, f of x is equals to, let's consider cube root of x plus 3 minus 2. This minus 2 is outside the cube root. Okay, now we need to find the graph of this function. All right, so here we have a cube root, right? So whenever we have a cube root, or f of x is equals to cube root of x, we said that somewhere down here, we said that the cube root is going to be, the shape of the graph is going to be like this, right? We said that. So yeah, we need to consider this as a base graph, and then we can get the graph of this new function. All right, so okay, here now, well, we know the graph of this one is something like this, right? So now if we have this extra addition and subtraction inside the function, then we are going to move either left or right. But here we have a plus 3. So if we have plus 3, then it's going to move to the left, right? So 1, 2, 3, right, left. And also we have this extra -2 outside the function. So that means it's going to move 2 units up. So from this point, it's going to move 2 units up. So let's say 1, 2. So that means our new graph is going to start from here. It's going to be something like this. All right, so the graph of this function is this. All right, clear? So yeah, you're going to see something like this on the homework and probably in the exam as well. All right, so yeah, this is it for section 1.1 and 1.2. I'll see you on next section, 1.3. Thank you so much.